Good morning, everyone. I'm Ryan Lei. I'm currently working at Meta as a tech lead and a Codec specialist. At the same time, I'm also working as a co-chair of the testing subgroup of AOM, driving all the testing-related activities and contributing to AV2 development. So today, I'm really excited to share with you some of the latest updates of the AV2 development and also some of the performance results. So the slide deck is taken from the material we prepared for the last year's ICIP conference. So a lot of folks from the AOM member companies contributing to this slide deck. So I want to acknowledge their contributions. Little bit history about the AOM. As you might know, Alliance for Open Media was created around 2015 by a lot of companies. And around 2018, the first generation coding standard called AV1 was released. And most of the algorithm and IP are from the three major proprietary codecs like VP10, DALA, and so on, and also a lot of contributions from many other member companies. So as of today, you might know like AV1 is already extensively deployed by a lot of member companies such as Google, Meta, and Netflix, and also a lot of streaming service providers. It's used in use cases not only VOD, streaming, live streaming, WebRTC, and also images as well. So around 2020, AOM started to explore the possibility to develop the next generation video codec. The actual work started around 2021. So at the beginning, we spent a lot of time to decide what are the starting code base we should use and also define the common test conditions. So I still remember at around 2022, I came to Mile High to present all the details about the common test conditions. So after that, we started actual work to evaluate all the coding to proposals at a weekly basis. And a lot of member companies contributing in different coding to proposal, and through the evaluation, we accept them as coding to candidates. And in parallel, there's a hardware working group and software implementation working group. They evaluate all the coding tools and provide suggestions for further optimization. So code base-wise, every about 3 to 4 months, we will have a release. After the release, the testing subgroup will conduct more comprehensive tests to evaluate the coding gains we achieved over the whole process. So after almost 5 years, right now we're at the time that wrapping up all the AV2 coding tools and start to write out the specifications. Hopefully, the final spec will be available around the end of Q1. But as of yesterday, the draft proposal is already posted on the AOM website. You can access right now. So from codec architecture point of view, the AV2 is still considered as conventional hybrid intra-prediction-based architecture. There's no AI or end-to-end neural network tools in the current standard. So basically from the encoder side, you still follow this intra prediction and then go through transform quantization, in-loop filter, inverse, all the entropy coding flow. So it's same as the same architecture as AVC, and this is easier for the hardware vendors to following the same approach to implement in hardware. And decoder side is kind of reverse process. You go through the inverse quantization, entropy decoding, inverse quantization, and finally generate the decoded videos. So now I'm gonna talk about some of the high-level coding tools. I don't know how much I can cover, but I will try see how much I can go. So at a high level from the partition point of view, so AV1 right now the largest super block size is 128 by 128. For each block, you have this 10 different partition options, and only the quadtree split option allows you to further split the block into smaller ones. All the other partition mode are basically they cannot further split the block. So in AV2, the improvement we first have is we increase the superblock size from 128 to 256. Then from each superblock, you have this up to 9 different partition options. And all those subblocks can be further split into smaller blocks. We call it the extended recursive partition option. So with this recursive option, then the first 3 mode split of vertical horizontal split plus the recursive already allows you to cover all 10 different partition options in AV1. And on top of that, we added also the H-shaped partitions in the middle, and also even 4-way partitions. You can partition your block into this 1:4:1 or 1:4:1 ratios to in both horizontal and vertical directions. So this gives you a lot of flexibility to adapt the coding block size based on the actual content. For larger blocks above 128, you only have these 4 different partition options. And on the right-hand side, you can see some of the highlight new coding block sizes added in AV2. From transform partition point of view, in AV1, so for inter or intra transform blocks, you can further split it into smaller blocks. For inter, you only have 2 options, either split or no split. In the split case, you basically split the transform block to be toward more square shape, right? And on intra, you only have 3 options to split. But in AV1A, we allow maximum up to 2 levels of split. So in V2, this is all redesigned. We removed the recursive option, so you can only split the transform block once, but you have all up to 8 different options to split them. So based on that, we also added some new transform block sizes, such as 1:8 or 8:1 ratios. We also supported the semi-decoupled partitioning. So in AV1, both the Luma and the Chroma block share the same partition shape. So in AV2, we decoupled the partition options between the Luma and the Chroma block. So when your block size is above certain size, the Luma and the Chroma block will share the same partition. But once you go down below that size, you have option to have separate partition shapes for Luma and the Chroma blocks. Few intro prediction tools. So for AV1, when you do intro prediction, you can only use a single neighbor pixel lines or column above and left to generate predicted pixels. So in AV2, we extended that to allow you to use one of up to 4 pixel line or columns to generate the predicted pixels. We also introduced this bi-prediction concept, which you can generate predicted pixels from your top right neighbors and bottom left neighbors, and then you blend them together. AV2 also supports data-driven interpredictions, which allow you to subsample your neighbor pixels and then multiply by some pre-trained matrix to generate the predicted pixel, and then you upsample them to go back to your original block size. Another coding tool called Chroma from Luma, which basically leverages the statistics from your Luma block to refine your Chroma interpretation. So this coding tool is introduced in AV1 already, but in AV1 we only support the fixed downsampling filter use 4 tabs. And then the whole process flow looks like that. So you first do intro prediction for your Luma block, and then you downsample it, and then you subtract the DC value from that Luma block, generated the AC component, and then you multiply by your alpha parameter, and then add it on top of the Chroma interpreted block. So in AV2, we further improve it to support different filter tabs for downsampling. And also we also added a mode where you implicitly calculated the alpha parameter on the decoder side, so you don't have to send it in the bitstream. So I probably don't have time to cover the rest of coding tools, but I want to skip to the most important slides. Sorry. Yeah, here. So if you don't remember what I just said, that's okay, but please, this is the most important part. So as I mentioned, after every release, the testing subgroup will conduct comprehensive tests to check the coding game progress. So the result I'm sharing here is based on the V11 anchor, which is released in last September. So right now we are at the V13 release. But in the past two releases, there's not too much actual coding gains. Most of the changes are integrating all the coding tools and fix bugs, all that. So if you can, on this slide, I'm showing you the coding gains in terms of BD rate when we compare to the starting point. This is for the all-intro configuration. So you can see we have a result for different classes of videos, different content. We calculate BD rate for all the popular quality metrics, PSNR, SM, VMAF, all that. So the one I want to highlight is if you look at the BD rate PSNR for value V, on average, we are achieving about 23% in terms of BD rate PSNR and BD rate VMAF. If you look at the screen content, which is B2, you can see the coding gain is about higher than 40%. This is the result for random access, which is the most important configuration for VOD use case. Again, the average coding gain is around 30% for BD rate PSNR, and for BD rate VMAF, it's close to 34-35%. Again, the screen content, coding gain for screen content is also higher than 40%. Low delay configuration, BD rate for PSNR around 25%. For VMAF, it's slightly higher. And also for screen content, it's all much higher. For still images, we're seeing close to 15%. And for adaptive streaming configuration, which is a new encoding configuration introduced in AV2 common test condition, which basically follow all the convex hub-based ABR encodings. Here, the coding gain for BD rate PSNR is 31%. For BD rate VMAF is close to 36%. So with V12 or V13, we expect maybe 0.5% or 1% actual improvement. So this is the progress of the coding game performance compared to the starting anchor with different releases. Here, the y-axis is the BD rate PSNR or BD rate VMAF. And x-axis is the release time of different AVM code releases. You can see over the past few years, we're seeing a steady improvement or progress on the improvement. With every release, we see a few percent actual coding gains. But from the last two releases, the coding gain seems plateaued, and we're not seeing too much actual gains. And also with different curve, we can see the coding gain from different encoding configurations. The last one, this is mainly the random access configuration coding gain in BD rate VMAF with different classes. You can see for the screen content and also the 4K HDR class, the coding gain is more than 40% right now. The bottom two curves. So takeaways, after almost 5 years of hard work, the development of the AV2 coding tools are complete, and we are in the process to writing the spec and integrate all the coding tools. At the same time, all these coding tools are heavily scrutinized by the decoder hardware vendors in terms of the implementation complexity. For the random access configuration, we are seeing about more than 30% coding gains in terms of BDW PSNR or BDW math. So right now we are working on prepare the subjective test or full kind of verification test. In terms of future work, the development for the production-ready software decoder and encoder already started. I think in a couple of weeks, we will see the software decoder AV2 will be on GitHub. I think it will be, I hope it will be available in a couple of weeks. The software encoder work also already started. So we are also started discussing whether we can develop an extension or actual profile to support some of the AI or ML coding tools. Yeah, so as I mentioned, this we have a full slide stack prepared for last year's ICIP conference. So if you scan this QR code, you can see all the slides, which will give you more details about all the coding tools. Okay, yeah.
Thank you. Thank you very much, Ryan.
Sorry.
Thanks
I hope
for the
I finished
presentation.
in the